right? How do we go about answering this? So the question asks that two forces of 10 newtons each are acting on an object. At what angle must these two forces act relative to each other? It's important. So that the resultant force of the two individual forces of 10 newtons must also be 10 newtons. How do we work this out? Well, what is the scenario? What tool do we use to find the resultants? Okay. Anyone? The tool that we use is the parallelogram of forces. Okay, you should have been taught this in grade 10. And it's a simple concept. Basically, if you have any forces, say this is 30 newtons and this is, I don't know, 75 newtons. Okay, then, and you want to find the resultant of these two forces. Well, you can just complete the parallelogram like so and draw in the resultant, and that gives you the resultant force. And you can just use your maths to figure out if this is also 30 because of the parallelogram. You can just figure out what that resultant is if you know the angle that they're acting on. Okay, so that's our tool. Now, how do we apply it here? So we know that two forces are acting relative to each other at a certain angle that we don't yet know. So I'm just going to draw in two random forces, okay? And because I don't know what they are, well, I know what they are, I don't know what the resultant is yet, 10 newtons. So I'm going to do what we normally do, right? Which is complete the parallelogram of forces. It'll be something like that, and then like that. That's the parallelogram complete. Now I'm going to draw in my diagonal. Okay, and this red line is my resultant force. Now this white line is 10 Newton. Well, it has a vector value of 10. We know why, parallelograms. That's equal to that. That's equal to that. Okay. Now, interestingly, we want this FR to equal 10. Okay, which makes this here, I hope you can see this. It's an equilateral triangle, right? What I'm outlining in green. That's an equilateral triangle because all the sides must be 10. What do we know about equilateral triangles? One fundamental property is that they have the same side lengths, yes, but they also have the same angle sizes. So all the angles of an equilateral triangle are the same, and that angle is 60 degrees. So because the diagonal bisects the angle, okay, we know that this is also going to be 60 degrees, and the angle relative to each other between the forces is going to be 60 plus 60, and 120 degrees relative to each other, right? So very simple sort of thing. You just have to think about it a bit. So a few people said 90 degrees. Why would that not have worked? Why would 90 degrees have not worked? So think about it. This is an important concept. So two forces, let's make this 10, and another force, also 10, and they act 90 degrees to each other. What would this be? So you have a box and someone pushes it this way, but then someone comes and pushes it this way. It's going to go that way, isn't it? So we just complete this parallelogram. Now this parallelogram is a square, I'm sure you remember from your geometry. And then draw in your resultants. Okay, now we call this the hypotenuse, isn't it? And we know, and it's going to be FR, the resultant, and this red line here is 10. So is it possible to get a hypotenuse in a right angle triangle being equal to one of the other sides or to both of the other sides? No, that's not really possible, isn't it? Because what's that size going to be? FR is going to be, well, FR squared is going to be 10 squared plus 10 squared, isn't it? So we take the square root of both sides. FR is equal to 100 plus 100, the square root of 200. And whatever the square root of 200 is, we know it's definitely not equal to 10. So it can't be 90 degrees. Hope you understand that. So it's simple. You just need to apply the methods. That's why I emphasize correct, or not correct, but accurate and useful, efficient methodologies like this, that you don't really need to think about the question too hard. You just go about the due process, apply the tools I teach you, and voila, you're in the game. You find out the answer. You don't have to always know how you're going to get the final answer, but you start by applying the method, and as you go along, the answers will reveal itself, because physics is simple in this sense, okay? As long as it's taught properly, and as long as you work with it correctly. use enough exposure, past papers, repetition, all of the normal things. Okay. Have a great week, guys. Any questions? You know where to reach me.